CVT belt to pulley clamping. The key to understanding how a CVT works is by reviewing how the chain and cone pulley react with each other. All CVTs have one weak spot, the contact point. This is where there is a tendency for the whole transmission to slip, grind and sustain damage. Incredibly enough, this is not where CVTs fail the most, but more on that later. The CVT belt is composed of two groups of metal rings, each of 7 to 12 rings, and a few hundred special metal links. It is these links, the ones with direct contact with the cone pulleys, or variators as they're called by the manufacturer. For good clamping force, the CVT needs a specific transmission fluid. To neglect this fact is to ask for trouble, as the CVT will get damaged due to slipping and grinding between the belt links and the cones. There's also another aspect of the CVT clamping force that needs to be reviewed, which is the hydraulic pressure exerted on the cone pulleys or variator. The CVT oil or hydraulic pump can generate as much as 1000 psi of pressure. But not everything in the CVT needs this much pressure. Because 800 or more psi is more than most circuits need, line pressure is regulated down to 3 lower levels, 220 psi maximum for the clutches and variator, 140 psi for the TCC, or torque converter, and 80 psi for the lube and cooler circuits. The CVT also has a few wet clutches, like a regular automatic transmission needed for reverse gear. All pressures are regulated by a series of pressure control solenoids, pressure sensors, and a TCM pulse width modulated control signal. Unlike the Honda CVT, most CVTs use a torque converter. Honda does away with the converter, and uses clutches instead. The purpose of the torque converter is to allow constant acceleration from a standstill, by providing a hydraulic disengagement from the engine. After driving away from full stop, the torque converter clutch applies very early, usually at about 14 miles per hour. The secondary variator pressure control solenoid controls the position of the secondary variator pressure control valve. This valve regulates the release of fluid to the oil pan from the secondary variator or pulley during movement from high to low gear ratio. Since the CVT depends mostly on the secondary variator to provide the necessary clamping force on the belt, it's very important for this solenoid and valve assembly to work properly. A fault with the secondary pressure control solenoid will send the CVT into limp-in mode, precisely so as not to cause damage between the belt links and smooth cone surface. The following DTCs will set if there's a failure in the secondary variator circuit or valve. DTC P0776, P0777, P0966, and P0967. The TCM will look at the secondary variator pressure sensor value, to determine if the solenoid is operating properly. If the actual values, and target value pressures don't match, a DTC will set. Keep in mind that CVTs work by pushing on the belt, and the right tension on it is of absolute importance. How does the TCM knows the CVT belt tension? Well, very easy, by monitoring the variator pressure sensor, and comparing this value to a pre-programmed lookup table. In other words, there's complete computer control over the hydraulic pressure, and hence, over the CVT belt to pulley clamping force.